Okay, we're in section 9 of the notes, and certainly a large part of this is to review what you've done in Math 119, which is basically rational functions. And in 119, when you did rational functions, you also did horizontal and vertical asymptotes. So really, basically, it's a review of that there. Of course, if you're reading your textbook, you realize there's a more precise definition of these infinities. But the bottom line is we'll still take the approach that you've learned in Math 119. So I'm going to go to the examples. We'll do the examples one at a time. I'll outline the work we'd like to see from you and the direction we'd like you to see you go in. All right, let me share my whiteboard with you. All right, so in 119, you were given rational functions and you were asked to compute the horizontal asymptote. All right, the way you did that, you looked at the rational going towards plus or minus infinity. The technique that your teachers outlined to you in Math 119 was to divide the top and the bottom of the irrational expression by the highest degree variable. Let's do that. X goes to infinity. Well, the highest degree variable here is x squared. So if you divide the top by x squared, rather simple, you get 9 minus 3 over x plus 4 over x squared. If you divide the bottom by x squared, what do you get? You get 5 over x squared minus 3 over x minus 11, right? The whole point of this is hopefully it makes it easier to do the limit, and it does. And the reason for that is this guy here, if you're dividing by an incredibly large number, goes to 0 very quickly. So does this one, so does this one, so does this one. So we're left off with 9 divided by minus 11. So you're left with 9 divided by minus 11. That's an inappropriate way to write a number. We would write down minus 9/11. What does that mean? We have a horizontal asymptote as x goes towards infinity. This function will actually start to look like the line y equals minus 9/11. Right? Answer's right over here. All right, relatively simple. Same thing that you did in Math 119. Okay, a little more complicated, but again, it's really the same thing. What we're looking to do is we're looking to divide the top and the bottom by the highest degree variable. Well, on top, the highest degree variable is x. On bottom, it's actually the square root of x squared. Let me write this down for you. The square root of x squared is actually equal to the absolute value of x. However, if x is going towards infinity, that's a positive number, and the absolute value of x going towards infinity is just x. All right, so I'm going to divide the top by this. I'm going to divide the bottom by this. Let's put that down. That's going to be limit. Again, x and the square root of x squared, when they go towards infinity, are identical. All right, so what are we doing over here? We're dividing the top by x because it's easy. You would get 4 minus 3 over x, and you're dividing the bottom by the square root of x squared. What would you get? 25 plus 4 over x. Again, the intent here is hopefully the limit becomes easier, and it does, because this shrinks to 0, this shrinks to 0. What are you left off with? 4 divided by the root of 25, which is 5, so it's 4/5. So what are we saying? That's the limit. And what are we going to say now? Well, it's got a horizontal asymptote as x goes towards infinity. And what is that horizontal asymptote? It will be y equals 4/5. The function starts to look just like that when you go towards infinity. All right, this one's a little different. It's looked at the same problem. So, well, it's got to be the same answer. Maybe, but let's take a look at it. What are you going to do? Well, again, the square root of x squared is equal to the absolute value of x, right? But when you go towards minus infinity, this is going to actually equal the opposite of x. All right. So, bottom line is what are you going to do over here? Let's take a look at it. And I got to write this down now. So limit as x goes towards minus infinity, and we are going towards minus infinity. I want to point out we're going to divide the top by that, and we're going to divide the bottom by that. And what do you get? Well, on top, if you divide by minus x, you get minus 4 plus 3 over x. On the bottom, we're dividing by the root of x squared. And what do you get over there? Well, you get 25 plus 4 over x. What does this give you? Well, looking at the limit, looks relatively simple to do. And what do we get? On top, we get -4. Again, 3 over x. As x gets incredibly large, but negative, it's still going to be 0. What do you get on bottom? You just get 5. So I got an answer. What does that mean? I have a horizontal asymptote as x goes towards -infinity, and that horizontal asymptote will be -4/5. All right, answers listed over here. All right, someone's going to look at this and say, well, I can answer this without doing any work. I'm not opposed to it. And what I mean by that, I'm not opposed to you putting an answer down for this one over here. I do want to go through the work though. And someone says, what is the work? The work is something that you write down and you try to communicate with someone else that you know what you're doing. But before I do that, I want to claim, kind of looking at it, I'm going to say these things are both going towards infinity and are roughly the same size, right? Then the problem comes is twice an infinity minus an infinity. What would that be? I think you get a good idea that might be an infinity. All right. Now, someone says it's not a precise reasoning, but you're getting a feel for it. All right. So what I want to do is, I can be deceived by getting a feel for something. I want to go through some work. Let's put the work down. Limit. Whoops, sorry about that. The limit as x goes towards infinity. This can be 2 root x minus the root of x plus 2. I'm going to put this over 1. And what I'm going to do is I'm going to multiply the top and the bottom. This could be a dead end, by the way, by the conjugate. What's conjugate? 2 root x minus, well, not minus, it's plus now, the root of x plus 2. And what do you get on bottom? 2 root x plus the root of x plus 2. All right, I'm going to look at this and see what I come up with. This is the limit. And again, you need to write the limit down. It goes x to infinity. The bottom's not bad. It's just simply 2 root x plus root x plus 2. What do you get on top? You get 4x minus x plus 2. And continue to work on it. Limit x goes to infinity. And what do you get? You would get 3x minus 2 over 2 root x plus root x plus 2. And here comes around where I'm going to say it's really clear to me. And I'm going to tell you what I mean by that. If you look at the top, its power is x. It's x to the first power. This is a root. Which one grows faster? This grows faster. This grows much, much faster than this over here. Now, when I say that, this thing here is going to go to infinity faster than this one over here. So what do I get over here? Plus infinity. All right. What does that mean? As we go towards infinity, this thing blows up. All right. Let's do this one over here. And again, I'm looking at it. My gut feeling is you should know about the arctangent from Math 120. And the arctangent function looks like this over here. So what do I know about it? I know the argument's defined everywhere. So what I'm going to do is I look in the inside. I'll write this down over here, arc, tangent, and I'm hoping I can do the limit of the inside. And what's that going to be? X goes to infinity, 1 plus x, 1 minus x. Before I say anything about this, you should know the arctangent function from Math 119. It's asymptotic with pi over 2. It's asymptotic with y equals minus pi over 2 over here. Again, our goal is to get you to try to think about this and write an answer down. It's going to be arctangent. Can I do the limit of the inside? I can. And I would divide through the highest degree variable. And if I did that, I'd get, maybe I'll write it down for you. Get my eraser out. Limit. X goes to infinity. That'd be 1 over x plus 1, 1 over x minus 1. Well, that's a fairly simple limit to do because as x goes to infinity, 1 over x goes to 0 very, very quickly. So you're left off with arctan of 1 divided by minus 1, which is minus 1. And yes, from Math 120, you should know this gives a number. And what does a number give me? Minus pi over 4. Let's look at our k, see how we're doing. Well, it's not there, so I guess on the next page. Minus pi over 4, as we said. All right, let's look at number 6. Again, for a lot of students, they look at it and say, I think I can do this without doing any work. We're trying to encourage work, though. All right, so what I'm going to look over here is, I realize I got a little bit of a problem. Neither limit exists, so I'm going to write it down as, I'm going to add those two things together. And what do you get over there? You get x plus 2. That's common denominator. On top, you get x plus 2 minus x. And I think I'm sort of ready to go forward. it's going to be limit x goes to infinity. I would get 2 over x plus 2. Well, now it's clear as day. The top is always going to be 2, and the bottom is going towards infinity. So this limit will be 0. All right, as specified. All right, let's look at this one over here. Again, it's a little more complicated because the absolute value. And I want to point out the absolute value of x as x goes towards minus infinity is the same thing as minus x. So let me write that down for you. Limit x goes towards minus infinity. Well, the absolute value of x when you go towards minus infinity is minus x. I'm going to keep writing this down. This is what's known as work, and we want you to do the work. What do you get over here? Well, minus x plus x is 0. And, I get 0. What is this limit? 0. That's done. Let's go to the next one. Someone says, oh, it's the same question. You type the same thing. Not really. The absolute value of x as x goes towards infinity is identical to x. Let's write that down. Limit x goes to infinity. That would be x plus 1. Let me keep writing this down. Limit x goes to infinity. That's 2x over x plus 1. What's our recommendation? The same recommendation we gave you in Math 119. Divide by the highest degree variable. That would be 2. 1 plus 1 over x. And that limit, and again, x goes to 0. I'm sorry, x goes to infinity, so 1 over x is 0. So we get 2. All right. You can clearly see there's two distinct limits there. And one goes to 0 up here, and the other one went to 2, depending on the direction you're going in. All right, let's keep going. Oh, wait a second. I think that's it. I think we're done. So what does that mean? You got to start thinking about what was presented to you. I want to claim, though, if you're reading a textbook, they have a much more precise method of doing these limits. And the bottom line is we're looking for an intuitive approach to it with a little bit of work, the kind of work that you did in Math 119. All right, so we're moving forward, understanding rational expressions, understanding limits at infinity, yada, yada, yada. You got to review. You got to study what came before, and then you got to move forward. And that's in the homework department. What's homework mean? You try to see if you can do those examples that we give you. All right, thank you.